Okay, lesson 5.5, last section and lesson of the unit. We're going to build off something we did in the past in a previous unit, but we're going to do it sticking with the theme. We're going to do it in 3 dimensions. So we're going to compare similar solids, meaning we're going to compare, we compared similar triangles, we compared similar polygons, we're going to compare similar figures. So what happens to their volumes as we create a larger version of it? Just like we did, what is the response of the perimeter or the response of the area as a two-dimensional figure gets bigger? And remember how the perimeter increased by the same factor. If the scale factor was 3, then the perimeter went up by a factor of 3. But if all the sides grew by a factor of 3, then the area grew by a factor of 3 squared. We call that the ratio of areas. So what about the ratio of volume? So right now we have volume equals 5 times 3 is the base times the height. So 15 times 20 is 60. And it says create a similar solid and compare. So let's make this, if this is going to be 4, let's make this 12. So right there, we've established a scale factor of 3. And we kind of just made that up. We could have done anything. That means this is going to be 15, and that means this is going to be 9. So the volume is 15 times 9 times 12. So notice what we did right there. This part got multiplied by 3, this part got multiplied by 3, and this part got multiplied by 3. So basically, this blue work is this red work with each of its parts multiplied by 3. So how many times was it multiplied by 3? 3 times. That's 16, 20. So the volume did not increase by a factor of 3. The volume did not turn into 180, which would have been 60 times 3. In fact, if the scale factor, actually is good on here, if a scale factor equaled 3 over 1, the ratio of volumes is 1620 over 60, which is 27 over 1. Meaning the volume got 27 times bigger. When the sides all got 3 times bigger, the volume got 27 times bigger. And the reason being is that's 3 cubed, which makes sense. Ratio of areas, we squared the scale factor. Ratio of volumes, we are going to cube the scale factor. That means if you have a scale factor of A over B, then the volume will change by A cubed over B cubed. So if a swimming pool with a volume of 10,000 cubic feet is rebuilt, and the person said, I want my pool to be twice as big, 2 times wider, 2 times longer, 2 times deeper. What is the new volume going to be? Is the volume going to double? Is the amount of water that we need going to be twice as big? So that's scale factor. And that would be the new over the old. So we're going to take that scale factor, and 10,000 is the old, so we're going to put that down below. What is the new volume going to be? Well, we can't just apply that scale factor. We have to cube that scale factor. So this is really 8 over 1 equals x over 10,000. So while all the dimensions are getting 2 times bigger, since there's 3 dimensions, each getting 2 times bigger, that's 2 3 times. That's going to be 8. 2 times 2 times 2. So x is going to equal 80,000. So the amount of water is going to be 8 times bigger. All right, identify the scale factor. So we can pick any. We can do 16 and 2, which is 8. We can do 24 and 3, which is 8. I'm going to go with 16 over 2. And that's going to be big over small cone. The ratio of the volumes. Now we can calculate the volumes of those cones. That might be some good practice. Or we can just say, if the scale factor is 8 over 1, then the ratio of volumes is going to be 8 cubed over 1 cubed. And 8 cubed is 512. And we could do that real quick. The volume here is going to be the base, which is pi r squared times 24 divided by 3. And the volume over here is going to be pi times 2 squared times 3 divided by 3. So volume of the big, volume of the small, those cancel out. And we get 4, because 2 squared is 4 pi. And over here, this gives us 8 times 16 squared, which is 2,048 pi. So my ratio of the volumes, big over small, is going to be 2,048 pi over 4 pi. And the reason why I didn't multiply that pi in there, which would give me a decimal, I would be forced around, so it would be inaccurate. Because look what's going to happen. This pi's are just going to cancel out. So really it's divided by 4, and we get 512. So it worked. This way, though, was much faster. Scale factor equals 6 over 10. We can simplify that down to 3 over 5. So the ratio of the volumes is going to be 3 cubed over 5 cubed, which is going to be 27 over 125. In your exit tickets and in your test, I'm going to have you guys write these in the format with a colon instead of a fraction. Just a little bit easier for me to write the problem that way. Remember the different ways we can write those ratios. All right, now we had this table in the past. Now we have another column. So we just had this table last time. We're adding another column. So here's the scale factor. Ratio of the perimeters is 4 over 5. We square that for the area. and we cube that for the volume. Remember, these columns are going to be the same, so really we didn't change anything up right here. This is going to be 7 squared over 9 squared, which is 49 over 81. 7 cubed over 9 cubed. Which is 343. $7.29. All right, now we're starting something got squared. So to go backwards, we're going to do the square root of 100, the square root of 121. So that's 10 over 11. Now we can go here. So this is going to be 10 cubed, which is 1,000 over 11 cubed, which is 1,331. Now to go backwards here, something got cubed to get to here. So we have to do something called the cube root. So the cube root of 64, the cube root of 27, meaning what did we cube to get 64? And the answer to that is 4. What did we cube to get 27? The answer to that is 3. There we go. All right, that's it for the unit. Make sure you guys work on the 5.5 homework. Remember, tomorrow is your pause day, so feel free to take your time on that. Starting tomorrow, starting next week, we will do a live review, and we will get ready for our Unit 5 test. Okay, make sure you guys get in touch with me with any questions.